Welcome, ladies and gentlemen, and welcome to the accumulation, the fundamental theorem of calculus. Basically, what this theorem states is the integral from a to b of f of x dx is equal to the antiderivative of f of b, my bad. F of b minus the antiderivative of f of a.
I know.
So you can manipulate this function into many ways. You can bring f of a over, so then it would be the integral f of a to b, f of x dx plus antiderivative f of a is equal to f of b. And a and b are x values, like they are here in the integral. You also manipulate this function to go integral you also manipulate from this function to get to get f of a by itself. You would bring f of b over, so integral a to b f of x dx minus f of b is equal to negative f of a. There you go. And to get rid of that negative, you're going to multiply both sides by -1. You see me do here. And then that leaves you with the negative integral a to b f of x dx plus f of b. Since we multiply this entire side by -1, it changes the f of b is equal to f of a. And there's also other different ways to write this function right here, like such. If it's given to you as negative b to a of f of x dx, you can also rewrite this as positive integral a to b f of x dx. Now let's do a couple examples to further explain this. So we are given the integral of what is it, 3 to 7 of f of x dx. And let's see, I'll give you the point. F of 7 is equal to 4. Find f of 3, which is basically this right here. Oh, excuse me. So, okay, I know she's gonna say something about it. So basically, it's the integral of 3 to 7 of f of x dx is equal to f of 7 minus f of 3. And I guess I say this earlier, b is always the biggest number on top, so always follow with that. So it's the biggest number minus the smaller number. And since we know f of 7 is 4, we can cancel that out. It'll give you 4 right there. So now it's the integral 3 to 7 f of x dx is equal to 4 minus f of 3. And like I said, we bring this 4 over, so it's the integral 3 to 7 f of x dx minus 4 is equal to negative f of 3. And then you multiply both sides by -1 to get rid of the negative. This gives you negative integral 3 to 7 fx dx plus 4, because remember that changes, is equal to f of 3. And this, on a free response, would be your answer because they did not give you f of x, so you don't have to plug in 7 and 3. Yeah. So let's see. Let's move on to another example. So let's see. We have the integral of 2 to 6. Let's do 1/3 x squared plus 2x dx. and you are, what is it? Oh yeah. Usually they'll just give you the integral like such, and then they'll give you a point. F of x is equal to, I mean, not f of x. Let's see. F of 4 will be equal to, give me. We'll just say it's equal to 12. Find f of 2, capital F of 2, since that is f of x. Excuse me. So you set the integral up as such. The bigger number is on top, 4. Small numbers on the bottom, 2. And we have our equation 1/3 x squared plus 2x dx. And the reason we can't just plug in 2 into the antiderivative of this is if we took the antiderivative of this, it would give us c. And to solve for c, we would need 2 points, the x and a y. At the moment, we only have x, so we're going to have to find the y. So the integral is equal to f of 4 is equal to minus f of 2. And like I said before, f of 4 is 12, so now we just have the integral to the 4 of 1/3 x squared plus 2x and dx. Wait, did I do this right?
Don't follow me, cut.
Then you bring over the 12, so it's minus 12 is equal to negative f of 2. Multiply both sides by negative 1. So, give me a minute, I'm trying to think.
We need you the math. Let's cut to commercial break.
No, hold on. No, we'll just leave it. Screw it. So, now it's a negative integral to the 4. 1/3 x squared plus 2x dx plus 12 is equal to... Josh, quit your crap. And then now we solve for the integral. So it's a negative, and then antiderivative inside. See that this is crap. I'm trying to think of this. I don't know. We're just gonna take away this 1/3 real quick from all the examples because this isn't making sense to me. There you go. Now it's just x squared plus 2x. There you go. Now antiderivative of x squared plus 2x is 1/3 x cubed plus x squared. But since x squared from 2 to 4 plus 12 is equal to f of 2. So now we plug in the 4 and the 2, so it's negative, let me see, 1/3 4 cubed plus 4 squared minus 1/3 2 cubed plus 2 squared plus 12 is equal to f of 2. There you go. And nope. Okay, that's shit.
Oh, I don't show the calculator.
No. 4 cubed times 1/3 is 19.2 plus 16 minus,
That's 8 over 3.
what?
8 over 3?
4 cubed?
No. This is 8 over 3.
Oh. Minus 8 over 3 plus 4 So then plus 12 equals f of 2. Then just combine these. 16. So it's 35.2 minus 20 over 3 plus 12 equals f of 2. Yeah, so 35.2 minus minus 20 divided by 3 gives you an estimate of 28.533. And since there's negative out here from the integral, it is negative 28.533 plus 12 is equal to f of 2. And just add 12, which will give you 40.533 is equal to f of 2. And that's pretty much it for the accumulation fundamental theorem of calculus. Thank you.